So in today's session, we are going to simply discuss questions on motion. My name is Arnold Kuramia. This is Kisembo Academy. We'll get started with number one. Now here they're saying that the speed time graph shown is for a car moving in a straight line. What is the acceleration of the car when the time is 40 seconds? So this is a speed time graph. That is speed, that is time. Now, the gradient for speed time graph, if we are to look here at the change in x, speed, because this is change in y, this is the y-axis, and this is the x-axis. Yeah. So we have to find the gradient of this, the gradient of this graph. Gradient is change in y, divide that by the change in x. In the change in y, we are having the speed on that axis. So we have the speed, divide that by, in the x direction, we have time. So speed divided by time, the rate of change of speed, that is what gives us, acceleration. Even by definition, we know acceleration to be the rate of change of velocity. Velocity and speed are similar things, only that speed is a scalar quantity, velocity is a vector quantity. So it means that the gradient of this curve is what is going to be giving us the value of acceleration. So if they're telling us that what is the acceleration of the car when the time is 40 seconds, we shall go to 40 seconds, which is right there, and we look at the point on the graph at 40 seconds, and we realize that at this point the curve is flat. So that means that the acceleration, the gradient of that curve at that point is 0. If the gradient at that point is 0, it means the acceleration at that point is 0. Our answer is A. Moving on to the next, we are being told that two runners are taking place in a race. The graph shows how the speed of each runner changes with time. So those are the graphs we are seeing there for each runner. What does the graph show about the runner at time t? Looking at this runner at time t, both runners are moving at the same speed. So if you look at time t, here this is the speed, and of course runner 1 and 2. When at that point, it's indeed true that they are at the same speed, right there. So A is true, but let's look at some others. Runner 1 has 0 acceleration. Well, if you look at runner 1, 0 acceleration, no. His acceleration is not 0. It is constant. Runner 1 is overtaking runner 2. Well, we can't determine that runner 1 is overtaking runner 2 because we do not have any information regarding their relative positions. We can tell the distance they have moved by just looking at the area under the respective graphs. For example, if you look at runner 1 and you want the distance covered for runner 1 is simply, the area under that graph, like that up to that point. And then if you want to look at the distance covered by runner 2, the distance covered by runner 2 would be the distance covered under the graph for runner 2 in blue up to that point. And you've realized that the area under the graph for runner 2 is bigger than the area under the graph for runner 1, meaning that runner 2 has traveled a longer distance. However, we do not know their relative points of where they started from. So it can't be correct. So runner 2 is slowing down. That is part D now. Runner 2 is slowing down if you look at runner 2. But if you look at the speed here, look, this is the speed graph. If you look at the speed, it's increasing throughout runner 2. As he's moving, the graph shows that as his graph progresses, his speed keeps increasing. However, his acceleration keeps reducing, but not his speed. So D can't be correct. So our answer is A. Both runners are moving at the same speed. Moving on. A car travels along a straight road. The speed time graph for this journey is shown, during which labeled part of the journey is the resultant force on the car 0. Now looking at that, where is the resultant force? 0. Now the resultant force will be 0 at constant speed, so our answer here is B. Remember that this is a speed time graph. And when you're looking at a speed time graph, the gradient of a speed time graph is going to give us acceleration. So in other words, the gradient of this graph is showing us the acceleration of this car. Now here the car is accelerating, accelerating. However, here the accelerations are reducing. So when it comes into this level, it is flat. The curve here is flat. It means there is no change in y, but there's no corresponding change in speed, much as the time is increasing, but there's no change in speed. So meaning that the gradient of this point is 0, acceleration is 0. So the answer is part B. Number 4, a large stone is dropped from a bridge into a river. Air resistance can be ignored. Which row describes the acceleration and the speed of the stone as it falls? So we're having a stone, it is dropped. Of course, ignoring air resistance, which row describes the acceleration and the speed of the stone as it falls. So now the acceleration, remember, as it's dropping, this is the ground. We all know that the acceleration due to gravity is it is 10 meters per second, or to be more exact, it is 9.81 meters per second. And this figure for acceleration is constant. It's always constant regardless of what you're throwing, how heavy it is, or how much mass it has, it's always constant. So it means that as far as acceleration is concerned, the acceleration will be constant. So in other words, here it's either A or B. For acceleration of the stone is constant. So what about the speed of the stone? Is the speed constant or is the speed increasing? So our answer there will be B. We are able to see this also on a graph. This is a graph of speed and this is time. This graph here shows that the rate of change of speed with time is increasing at a constant rate. The gradient is constant. And this shows that the object here is accelerating. So if the object here is accelerating, you realize that if that shows that there's acceleration, but on the side of speed, remember the speed here keeps increasing. So yes, whereas the acceleration of the stone is constant because acceleration due to gravity is fixed 10 meters per second, well, the speed will be increasing in the process. Maybe another way to look at this is when you are driving. Now I'm talking about common life here now, real life. You're driving and you've been driving at constant speed. Then all of a sudden you need to overtake someone. When you're overtaking someone, of course, you're going to have to press the accelerator pedal so that overtake a car that is in front of you. So as you're overtaking this person, you pressing that accelerator pedal, yes, you are accelerating, like this graph suggests that yes, you are accelerating, and accelerating simply means that the rate of change of your speed is increasing. So definitely, as one accelerates or as this stone is accelerating down to the ground, its speed increases. So that's another way to explain B. So that's it for number 4. Let's get into the next one. Number 5. Below are 4 statements about acceleration. Which statement is not correct? So here we are interested in the statement that is not correct. So a statement that is not correct, we have here acceleration always involves changing speed, changing direction always involves acceleration, changing speed always involves acceleration, and celestial motion always involves acceleration. In other words, okay, this may look a bit confusing. They are stating something here, and when they say changing direction always involves acceleration, in other words, when you change direction, acceleration is involved, or in other words, acceleration is affected, something like that. Changing speed always involves acceleration. Well, maybe to better understand this, let's first get back to the fundamentals. We have what we call We have displacement. Let me do it here. Then we have distance here. Then we have speed. Yeah. Now, just so you should know, we have this displacement and distance are the same thing, right? Or let me put it this way. Displacement and distance are related. They have the same SI units, only that distance is a scalar quantity, displacement is a vector quantity. By the way, all these ones here are vector quantities, and all these ones here are scalar quantities. By now, you should be able to know that vector quantities have both magnitude and direction. Scalar quantities only have magnitude, they do not have direction. So distance and displacement, their SI unit is meters. However, the difference here being that distance is just a magnitude, but displacement has both magnitude and direction. The same thing is with speed. Speed and velocity, their SI unit is meters per second. So meters per second is both the SI unit for speed and velocity. However, speed only has the magnitude, velocity has both magnitude and direction. And then we move on to acceleration, which is a vector quantity, and so meaning acceleration has both magnitude and direction. By definition, we know that velocity is the rate of change of displacement. And at the same time, we know that acceleration is the rate of change of velocity. So I'll come here and say acceleration is the rate of change of velocity. I just needed to give that sitemap or that overview so that we know where we are at. Now the question is talking about acceleration. So let's concern ourselves with this. I just wanted to give you a background here. So acceleration is velocity, rate of change of velocity with time. Now remember, like I said, whereas acceleration is the rate of change of velocity with time, acceleration has magnitude and it has direction. The magnitude part of velocity is the speed and then the direction. So if when we are accelerating, let's say when we are driving a car and we are about to overtake, when the speed increases, which is the magnitude part of the velocity, when the speed increases, this normally increases when we are going to overtake a car, it means the acceleration is also going to be affected as a result. And also think about it this way, that let's say if you're driving and you turn that wheel, you turn the wheel of the steering wheel, you turn it. It means that your direction is also going to change. And because your direction has changed, that also is going to affect acceleration. Now, many people confuse acceleration and velocity to be the same thing. These things are not. Uh, the normal understanding of velocity or speed is not exactly acceleration. So what you should know is that acceleration will be affected when the speed either increases or decreases. When speed increases or decreases, the acceleration will be affected. And at the same time, when you are driving something and you change the direction, the acceleration will be affected. So because the acceleration will be affected, if you look at our objectives here, they are telling us that acceleration always involves changing speed. Now, when the speed changes, yes, acceleration will change. That is true. But changing speed is not the only thing involved here. There is changing speed and then there is changing direction. If you look at B, it says that changing direction always involves acceleration. That is true. Changing speed always involves acceleration. That is true. Circular motion always involves acceleration because when an object is in circular motion, let's say this is an object, when it moves there, when it comes here, its direction has changed. When it comes there, its direction has changed. So this constant change in direction is going to cause a change in acceleration. Sure, so this is also true. However, when you look at question A, they are saying now acceleration always involves changing speed, but it is not the only thing. Now acceleration is broad here. We are coming from here, from acceleration to explain what causes it to change. Acceleration does not only involve changing speed, it involves both changing speed and changing direction. So if we are to fish out the statement which is not correct, we would say it is statement A. And we would say statement A is not correct. Why? Because it is saying that acceleration always involves changing speed. The right statement would have been acceleration always involves changing speed or changing direction. But here the statement is only saying that acceleration always involves changing speed, meaning that it's dismissing changing direction, which is not correct. So the statement is A. That's the correct one. Next, an object moves at a constant speed for some time, then begins to accelerate. Which distance time graph shows the motion? So this is distance time. And remember that the gradient for distance time graph is going to give us velocity, or actually it's going to give us speed, because distance divide that by time gives us speed. So the rate of change of distance is speed. These are all scalar quantities. So they're talking about that an object moves at a constant speed for some time, meaning that if it is moving at a constant speed, it means that the gradient of this graph is supposed to be constant. So let's look at this. This is out because this is not constant speed. Here it is this is not constant speed. Here the gradient is increasing. So here the speed is increasing here and there. This is not constant increase in speed. So it's either B or C. However, they're saying that an object moves at constant speed for some time, then begins to accelerate. So here it moves at constant speed, then after moving at constant speed, now the speed starts moving at an exponential rate. So the answer is C, that we have constant speed first, then afterwards it accelerates. Next, an object is released near the surface of the earth and falls freely. Air resistance can be ignored. Which statement about the acceleration of the object due to gravity is correct? A. The acceleration depends on the mass of the object. That is incorrect. Acceleration is not influenced by mass of an object. Then next, the acceleration depends on the volume of the object. Acceleration is not influenced by volume of an object. So B is also incorrect. The acceleration is constant. Yes, this is correct. Then maybe D, the acceleration is initially zero and increases as the object falls. No. The acceleration due to gravity is always constant. So the answer is C. Next, a car moves with constant speed and then constant acceleration. Which graph is the speed time graph of a car? So it first moves at constant speed. So the graphs here that are showing moving at constant speed, we have this right here. We have this graph here moving at constant speed first, because it's saying that moves with constant speed first. However, this one, there is no speed here. The speed here is zero, so it's actually not moving. So we only have this one moving at constant speed first, then constant acceleration. So after moving at a constant speed, then it moves at a constant acceleration. The gradient here is constant. Remember, this is a speed time graph, and speed time graph gives the gradient is an acceleration. So the answer here is C. A car travels 100 kilometers. The journey takes 2 hours. The highest speed of the car is 80 kilometers, and the lowest speed is 40 kilometers. What is the average speed for the journey? So we all know that distance is given by speed times time. If we make speed the subject of the formula, speed is given by distance over time. So what about average speed? Average speed is given by total distance, divide that by total time. And looking at our question here, we just need to know the total distance. So they are telling us that the car travels 100 kilometers, so meaning that's the total distance of 100 kilometers. Divide that by the total time, and it takes 2 hours, so it's 2 hours. And this gives us 50 kilometers per hour. So this is the average speed. And our answer here is B. It's supposed to be K. So what does the area under a speed time graph represent? This is speed time graph. This is speed, that is time. What does the area under this graph represent? Let's say we have a graph like that. Speed time graph. Speed is in meters per second and time is in seconds. If we're having this graph moving from this point to that point, let me shade the area under this graph. That is the area under the graph right there. So I want to find this area. Of course, if I'm to find the area of this graph, the area there is going to be equal to a half times the base times height, because it's a triangle, right? So that's going to be a half times the base. Now, the base here is representing time, because it's on the time axis, so times the time, whatever time is there, times the height. So this will be our height right there. And our height there is the speed, right? Now let's look at the units involved in the answer we shall be getting. This is going to become a half times, okay, let me put the half, multiply that by the time. Time is in seconds. Multiply that by the speed. Speed is in meters per second. So it's times meters per second. You realize that the seconds will cancel out and you'll find that whatever answer you'll be getting here will be in meters. So if the final answer we're getting is in meters and they're telling us that what does the area under the speed time graph represent? Well, it's going to represent something whose SI units are meters, and we know that the SI unit for meters, it is distance. So meaning that here it is D. The answer is D. That the area under a speed time graph is going to represent the distance traveled. That's how we get to know. So moving on to the next. The speed time graph below shows the motion of the car. Okay, which row describes the motion? Of course, speed time graph is right there. The gradient of a speed time graph is going to give us acceleration. Here we consider that this is here a car is accelerating. Since the gradient of this line is constant, in other words, the rate of change of speed is constant. So here it is accelerating, then when it reaches point Q and then it moves flat, the velocity, the gradient here is 0. So meaning that here it is simply moving at a constant speed. It was moving from 0, the speed increased to some level, then it starts moving at constant speed. And we know that when an object is moving at constant speed, acceleration is 0. Acceleration is 0, meaning that the velocity is not increasing. It is at a constant, the velocity is constant, or the speed is constant. So which row describes the motion? P and Q, of course, it is accelerating. It's either A or B. That is correct. Then we move to between Q and R. Moving at constant speed, yes. Not moving, no. So the answer is A. Question 12. The graph represents the motion of a car. What is the distance traveled by the car while it is moving at constant speed? So if you look at the parts of this graph here, it was accelerating. Here it was decelerating. Then here it was moving at constant speed. Then here it decelerates. So what is the distance traveled by the car while it's moving at constant speed? You realize that it's moving at constant speed only under this portion of the graph. That's the only part where it is moving at constant speed. After identifying the part where it's moving at constant speed, all we have to do is to find the area under that graph. And the shape of the graph is more like a rectangle. So we know that the area under that graph is length times width. We know that the length here, for example, here this is 10, here to there is 10. So it's going to be 10, multiply that by the distance from there to there will be 25 minus 15. 25 minus 15 is 10. So you will end up with 100 meters. So that is A. So the distance traveled by the car while it's moving at constant speed is 100 meters, which is A. Then number 13, a car travels along the route PQRST in 30 minutes. What is the average speed of the car? We already mentioned earlier that average speed is given by total distance, divide that by total time. So what's the total distance? Of course, it moves from here to there. We have 10 kilometers there, plus the 5 kilometers, plus the 10 kilometers, plus the 5 kilometers. All this is in kilometers. Divide that by the total time taken. The question says that it travels in 30 minutes. So that is 30 minutes, yeah? So I'll come here and say divide that by 30 minutes. But if you look at our answers are in kilometers per hour. Kilometers per hour. This is supposed to be kilometers per hour, kilometers per hour. So our answers being in kilometers per hour means that we are supposed to make sure that up here our numerator is kilometers per hour. This 30 minutes should be converted to hours. So it's going to be 10 plus 10. This is 30 kilometers. Divide that by, now 30 minutes is half an hour. Half an hour. So that's going to become 30 kilometers. Multiply that by 2/1. And then we shall end up with 60. So it's going to become 60 kilometers per hour. And our answer there is D. So our answer here is D. The table shows the readings on a car speedometer at 5-second intervals right there, which row describes the speed and the acceleration of the car. So of course this is time, it's increasing at every 5 seconds here, the time. So the speed from here, we can see that speed moves from 0 to 30 to 50 to 60 to 65. So definitely the speed is increasing. So A and B are ruled out. The speed is increasing. Then what about the acceleration? They are telling us that the acceleration is 0. The acceleration can only be 0 if the speed is constant, but in this case we are saying that the speed is not constant, it's increasing. So in other words, so meaning that the acceleration is not 0. So the answer is D. And finally, the diagram shows the distance time graph for a car, which labeled point is the car moving with constant speed. Now this is distance time, and we know that the gradient for distance time gives us speed. So if the gradient for distance over time is constant, if the gradient is constant, then that's where the speed is constant. So it's inconstant at part A. So that's the answer. This brings us to the end of this revision session. Thanks for watching. My name is Arnold Rangakuramia, and this is Kisembo Academy.